Okay, today for the Flux Day we are going to work on overlapping triangles, and all overlapping triangles are going to be triangles that share a common side or angle as they are overlapped. So within these diagrams, each one of them is going to look a little different, but the triangles are going to share some common side or common angle within the picture that you're looking at. Please feel free to pause this as I go through if I'm going too fast, but I'm going to go through each one of these examples, and I'm going to first separate and redraw the two overlapping triangles. So it should tell you in the directions which triangles we're looking at. Some of these diagrams can be kind of confusing. So this says Z, X, and W. So I'm just going to trace that as it's written. Z, X, W. And the other triangle is W, Y, or sorry, Y, W, and X. There we go. So here's my second triangle. Now, the easiest thing I can tell you guys to do here, literally like come down, and it doesn't have to be perfect, but I'm going to come underneath this and I'm going to redraw the two diagrams, or the two triangles in that diagram separate from each other. Okay, and they do have some markings in the picture for some given information. We'll get to that in a second. But I would also encourage you to relabel the triangles after you have separated them. Okay, now you guys can actually see this in the picture, but it's kind of confusing because in the original picture they're overlapped. So I'm just going to mark these angles. So ZXW, in that original picture, that has a triple mark on it, triple curve, and YWX, you guys will see that here as well in the pink one. I'm just going to go 1, 2, 3 to match up with the diagram. Now, they also give you another set of angles, ZWX. In the original figure here, it's this whole angle that's got a double curve on it, so I'm just going to go like that. And YXW, whatever letters in the middle for each one of these, that's the vertex of the angle. Okay, so in terms of my proof, we're going to try to prove that these two triangles are congruent, but I'm just going to write down both of those pieces of information that I remarked in my new diagram were given to me. Okay, now with overlapping triangles, you want to go back to the original picture and you want to look for what sides or angles they might have in common. So what you guys might notice, that original diagram, both of those triangles have that side WX. So I'm just going to mark that real quick in my new diagram with both the triangles separated there. And I'm going to say that segment WX is congruent to WX. Just your reflexive property, I'm saying a segment is equal to itself. And then, why are the triangles congruent? Well, I have an angle, a side, and an angle in both of these guys. It's much easier to do these problems if you separate the triangles and then redraw the given information. Okay, so let's slide up to the next example. It tells you which ones to separate and redraw. So I'm going to grab, here's A, C, B. And the other triangle, P, R, B. Okay, again, I try to kind of do my best to make them look similar to what they did, but it doesn't have to be perfect. So that one is my ACB, and I'm just going to try to keep the color I used consistent here. And I'm not doing the greatest job, but this would be the P, the R, and the B. And then I'm going to come over here with what they give us. So PB, that's this segment here, and AB, that's this segment here, are congruent. RB, that's this segment here, and CB, this segment here, those are congruent. So I'll just go ahead and start writing those triangle parts in my proof. Set of sides RB congruent to CB, another set of sides. Both of those were just given to us in the directions. Okay, now this one's a little tricky, and we have never used this before in a proof because we haven't had any overlapping triangles like this. If you guys look back to the original proof, see if you can, or the original pictures, see if you guys can see both of these triangles have an angle that they have in both of them. We've never used a reflexive property for this, but we are going to here. So this angle, that angle B, right there, is in both triangles. So sometimes this happens with overlapping triangles. You can have an angle that they share. So angle B is congruent to itself, just like we've been doing. These have always been segments in our previous proofs, but for overlapping triangles, there's a possibility you can have a shared angle, which is what we have here. So angle B in both of those triangles, it has to be equal to itself. And then if you look at your triangle congruent statement here, it says ACB and PRB, those are corresponding. All you got to do is check what you have. We have a side, we have an angle, and we have a side. So that's going to be my justification for why those two triangles are congruent. Okay, so on the front side we were just proving two overlapping triangles congruent. On the back we're going to have an extra step to each proof because we're going to prove either a segment or set of segments or a set of angles are congruent, but the same as the front. Make sure you separate and redraw the two triangles. So GFD is this guy here, and then we have GHE here. Okay, so just, it doesn't have to be perfect, but just kind of somewhere below here. Sorry, my marker's about to die, so let me just grab this. And you guys can pause this at any time if I'm going a little too fast. Those don't look great, but we're doing our best here. This one is the one I have highlighted in green, GFD. And then the pink one, this would be G, this would be H, and this would be E. Okay, so let me just start and we'll just mark some given information. So segment DF right here is congruent to HE right here. And, okay, when you're doing angles, if they give you angles that are congruent, the middle letter is the vertex. So GFD is going to be this angle here, and GHE is going to be this angle here. Okay, so let me just start and write those triangle parts in the proof. Remember, triangle parts are the most important part of the proof because you need at least 3 sets of corresponding and congruent parts to be able to show that the triangles are congruent. So that's what I'm looking for in each of those first 3 steps, either sides or angles that you know are congruent. Both of those justification would be it was given to us. Okay, now, no more given information, so we got to look back to the triangle. If I'm trying to prove parts congruent, I have to show the triangles are congruent first. Have no way of knowing if those segments are congruent from the diagram. What we could have, though, if you notice, this is kind of like the problem we just did. Both of these triangles have angle G as part of their triangle, so I'm going to put a double curve on that because I don't know if it's the same as the other angle. And I'm going to say angle G has to be congruent to itself. It's in both triangles. That's just a reflexive property. Now, I've got to complete my congruent statement. So we're going to say these two triangles are congruent. This is labeled DFG. So I have to kind of map the other triangle, and it's a little weird because it's kind of flipped over. But D to F would correspond with E to H. And if you guys see the F and the H both have a single curve, then we're going to go up to G here, we're going to go up to G here, so this should finish out with G. We have angle, angle, side as the reason the triangles are congruent. And now, if I have the triangles congruent, it forces all the corresponding parts. So GH is here, and GF is here. So we didn't know this as we were doing the proof, but now, because we've shown the triangles are congruent, that forces all the corresponding parts to be as well. So even though I didn't know that, now I'm going to be able to conclude those two segments, because they're corresponding, are congruent to each other. Justification for that is corresponding parts of congruent triangles are congruent. Before you can use that, though, you have to show why the triangles are congruent. Okay, now finally we have one triangle set left here, and I apologize, I forgot to write down on this example on the paper which triangles we're going to redraw. So see if you guys can see this from the picture. If you look down to my congruent statement, we're going to use SFG. So I'm going to grab that triangle, and just in the space here, I'm just going to draw that separately real quick. And the other triangle I'm going to use is HFG here. So just kind of do the best you can. It does not have to be perfect, but if you separate them, a lot of the times they're much easier to work with. So this would be the S, the G, and the F. This is going to be the H, G, and F here. Okay, so let me just go ahead and mark up the given information from the directions here. So whatever letter's in the middle, if they're talking about angles, that's going to be the vertex. So SFG would be this angle, and HGF would be this angle. Then they're going to give us a set of segments, FS and GH. So I'm going to mark those, and let me just go ahead and start the proof there. I'm going to say angle SFG congruent to angle HGF, and set of angles. And I'm going to get a set of sides here. Try and get my 3 sets of triangle parts. These are given. And I want to look back to the diagram to see if those two triangles share any sides or angles in common. In this diagram, I'm going to argue that FG is across the bottom of both of those triangles, and so that part I'm going to use the reflexive property with, but that segment is the bottom of both of those triangles. They're turned in different directions, but that segment, it has to be the same length in each, so it has to be congruent to itself. So this is reflexive. Okay, complete the congruent statement. SFG, so I want to make sure I go in the same order. It's a little tricky because this triangle is flipped over, but if I go SFG, I have to label the other one HGF. The S and the H are going to correspond, F and G are going to correspond, they got that congruent angle, and this G and this F are going to correspond. Here you've got a side and angle and a side. And so now I've shown these two overlapping triangles are congruent, so even though we didn't know this, it's going to force any other corresponding sides or angles. So FH and SG or GS, those are going to be corresponding parts. So we showed the triangles are congruent. So even though we didn't know it forces these segments to be congruent as well. And the justification, corresponding parts, that's this set aside, of congruent triangles, we showed the triangles were congruent, have to be congruent.